Welcome to the Stormsurf video surf forecast for the week starting Sunday, June 23rd. Looking at significant wave heights for the South Pacific Ocean, we see a vastly improved pattern. A gale is pushing under New Zealand, producing 41-foot seas aimed to the northeast. And if one is to believe the models, this is not the end of it. There's more behind. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for a trough. That is a push in the jet to the north, just like here. And that is a pretty decent looking trough with 160 knot winds pushing to the northeast. That helps support a clockwise flow aloft, and in the southern hemisphere, clockwise flow is a sign of low pressure. And low pressure in the upper atmosphere and down in the lower atmosphere creates wind, of course, and winds generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, wherever that might be, like let's say over here in Peru, that produces surf. All right, so we have a pretty good, healthy, energetic trough pushing under New Zealand here, but we also have a pretty good ridge pushing to the south over the rest of the South Pacific, and that promotes high pressure aloft, and that just squashes storm and swell production. All right, so here is our area of interest. Let's put this into motion. See what we got. That fetch, or the trough, continues into, let's say, Monday morning, and then it starts weakening and washing out. The ice line is right about 65 south here, so you see the peak of the trough. We're back here. Let's go back, take a look. Peak of the trough is up around 58 or so north. The ice line's down around here. So there's a little pocket here of ice-free waters where wind actually would get traction on the ocean surface. But as we get down into like later Monday night, not so much, not looking so good. And we have that massive ridge in the east just crushing everything there Wednesday. Looks like a little bit of reinforcements to the ridge comes in on Thursday and actually pushing even further to the south down to 70 south, well over the Ross Ice Shelf there. But then as we get into maybe Friday night, Saturday, another trough starts building and pushing, sweeping off to the east into Saturday and even a bit into Sunday, and building and coverage winds back off. Oh, and we're almost, there we go, at 180 hours. Pretty good trough holding even into almost Monday, a week out. If you believe a model a week into the future, which we don't, take it with a grain of salt, but it is kind of interesting to see whether this will materialize. Next off, let's take a look at surface level pressure, surface level winds. Here's New Zealand, of course, Ross Ice Shelf. You can't see it on here. We'll see it on the wave models. This area down here is covered by ice. So you see fetch pushing from the south. That's all over ice. It's not doing anything. Literally no wind blowing on the ocean surface. It's blowing over solid ice there. But south of New Zealand, here we go, 40, 45 knot winds aimed off to the east northeast. Probably getting pretty good traction on the ocean surface, continuing into this evening and then starting to fade as we get into Monday. But a secondary fetch pushes through Monday night, again with 40 knot winds from the west-southwest aimed pretty well to the northeast. Maybe a little secondary fetch there, and then that all kind of fades out. And then look at here, as we get into Wednesday, this is the 18Z run. This is even stronger than it was on the 12Z run. 45 knot winds aimed from the southwest to the northeast, building to 50 knots Wednesday morning. This is looking, just actually quite productive. As we get into Thursday, even more fetch. And then here we go as we get into Friday. A broad system starts developing under New Zealand. 45 knot winds, almost 50 knots under a little area there. And then building solid 50 knots, maybe even a little bit more under New Zealand on Friday night into Saturday morning. Continuing pushing off to the east into Sunday. This is pretty impressive system here, much more positive than anything we've seen in quite a few years. Will it materialize? Who knows? Way too early to tell. All right, let's go look at the wave model. So we're actually going back in time. We're going to Saturday. So what was this, about 24 hours ago? A gale developed under the Tasman Sea right there between New Zealand and Australia. 40-foot seas over a small area. Then building to 41 feet. In fact, here, maybe we can pull this up just a little bit. There you go. 42.9 feet to be specific on Saturday night. And then what did it do from there? Faded a little bit, but here we go. Here's here we are right now. Secondary fetch producing 40 footsies, 41.8 footsies right now. Whoops. All right, and now let's go into the forecast. And here we go. 41.4 footsies into this evening, Sunday evening, and then fading from there. I mean, that alone is generating swell, radiating north towards Hawaii and the U.S. West Coast and Peru and Central America. But then a secondary fetch is supposed to develop under that. We saw that on the surface level pressure models with like 33 footseas. Now that's nothing particularly impressive. And yet another one as we get into Wednesday, you know, this is what, 30, 32, 34, 30, we'll say 35 footseas. And, oh, there we go, to 36 feet as we get into Wednesday, Thursday, and then even a little bit beyond that. So, I mean, this is swell starting in Hawaii, let's say a week from today, and into California maybe late Monday, a week out, or Tuesday, and then some degree of swell for probably the entirety of the week following that. And then you go, okay, you're going to be surfed out, and then supposedly, if you believe the model, look at this. We get into Friday night, what's that, 5 days from now? We have 45-foot seas, building to 49 foot, building to 50 feet, pushing under New Zealand, Saturday a week from now, and continuing, and slowly just tracking the whole way across the South Pacific. And we're at 180 hours out, and it looks like this thing is not over yet. I mean, this could be a significant swell event if it were to happen. Major quotes around the if. We're a week out. The models, actually, they've been doing pretty good. In fact, Noaa upgraded the GFS model, and that's what's driving all this. It was version 14, it's up to version 15. Some new physics involved in it. They're also picking up data from the buoys now, and a bunch more satellite data. So that theoretically should improve the accuracy of the model. We'll see. They've been testing it for the past couple of years, and so when they say it's better, one would believe that they've tested it and quantitatively verified that it is better. So we'll see. Let's say next Sunday when we do this video again, if we have something very good to report, then we'll know the model is significantly improved. All right. All that aside, right now we have small southern hemiswell hitting California, nothing hitting Hawaii, and things are going to get rather flat. Our only hope is wind swell. So let's go examine, and we're talking about just for the net for this work week into next weekend. Let's take a look. We've got, yes, we have fetch. So this is high pressure in the Gulf of Alaska, clockwise circulation. You can see the wind barbs here, and then heat, low pressure inland. When the two of those get close, you get what they call a gradient, a tightening of the isobars, like right there, and that produces wind, 25, 30 knot north winds. Doesn't take much, and you get little wind swell radiating down into central California, northern California. Hawaii, not a whole lot going on. You need a minimum 15 knot fetch over maybe a 400 or 500 nautical mile area. We're not seeing any of that there. So let's roll it out, see where we go. We get into Monday, yes, fetch continues along the north California coast, making wind swell, nothing east of Hawaii. And then as we get into Tuesday, the fetch starts collapsing. Notice this low pressure, very weak low pressure off the Pacific Northwest, kind of cutting the legs off the gradient, at least for the time being. Wind swell starts dying out. Where are we? We're into Wednesday now. No wind swell, nothing for Hawaii either. We get into Thursday. Little bit of a gradient over Cape Mendocino. Maybe that'll produce some wind swell into select breaks in maybe Southern California, but for the most of California, north of Point Conception, probably not a whole lot. And then also Thursday, notice this. Boom, it just lights up. We'll go from there. 15 knot winds. Here's our high pressure, 1028 millibar high, building in, producing east fetch, right? Clockwise circulation around the high. Produce each fetch pushing into Hawaii. So maybe some building, and as we get into the evening, building east wind swell along exposed east-facing shores of the Hawaiian Islands. Then a even more solid fetch into Friday morning, good for Hawaii. And the same sort of situation in California on Friday. Just, Point Conception, maybe Southern California, some wind swell. nothing otherwise. Even into Saturday, fetch continues off of Hawaii, east of Hawaii, making for wind swell there. Nothing really for California. And Sunday, the fetch looks to be starting to fade for Hawaii. California, not even really wind swell to speak of, and we're 180 hours out. And by this window, we're more interested in southern hemiswell hitting Hawaii and approaching California. So from a wind swell perspective, probably a declining pattern for California, but an improving pattern for later in the week for Hawaii. All right, let's go look further out. All right, what's going on with the MJO? Why we always talk about the MJO? Because the MJO forces changes in the jet stream. When in the active phase of the MJO, that helps support storm formation in the North Pacific in winter months there, and in the South Pacific when it's winter down there, which is right now. And then, of course, El Nino, which is like either a long-running inactive or active phase of the MJO. As usual, we like to look at winds on the equator in the West Pacific. This is the East Pacific here. This is the West Pacific here. 0 degrees, that's the equator. Dateline, 180 degrees, so this is the Pacific Ocean, right? And the wind data, 5-day average winds from the TAO buoys array, a series of buoys strung across the equator used for monitoring the presence of El Nino. 5-day average winds from the east over the whole East Pacific, Central Pacific. But notice as you get into the West Pacific, those east winds really start dying, and you actually see west winds starting to blow. Not west anomalies, but actual west winds. That's a hint that the active phase of the MJO is in control of the West Pacific, and that, in turn, would be feeding the jet stream and helping feed the trough south of New Zealand, which is making swell at this very moment. All right, anomalies, differences from normal for this time of year. Yeah, we have east winds. That's normal this time of year, and they're not stronger or weaker than anything normal in the East Pacific. Central Pacific, maybe a little bit stronger. You see some arrows out of the east. But when you get into the West Pacific, these west arrows or light winds here means we have westerly anomalies here. That is good for feeding the jet stream, and if they stay westerly long enough and strong enough, then that could possibly help create a Kelvin wave, assuming there was enough warm water over here in the West Pacific, which there isn't, and enough if you have successive Kelvin waves, that helps form El Nino. We'll get into that in a minute. What have winds been doing for the past 5 days? All right, South America there, Central America there, New Guinea there, the dateline right there, the equator right there. Kelvin wave generation area, the area we're really concerned with, the West Pacific basically. 170 west, 5 degrees north and south of the equator. Draw a box in your mind right in that area. See oranges, you see the arrows coming from the west. So this was, what was that, the 17th of June? Weak westerly anomalies, same thing on the 18th, 19th, 20th, 21st. It doesn't matter. They have to be on the equator, just 5 degrees north and south. So past 5 days, yeah, there's been little bits of easterly anomalies, little bits of westerly anomalies, but basically just a neutral pattern. But then we can look at the forecast. What's supposed to be happening? All right, so this is the whole planet on one chart, right? So 180 west is the date line, and this is for zonal wind anomalies. Basically, you can't see it, 5 north, 5 south of the equator. That's basically in the Kelvin wave generation area, if it's between these two tick marks going up. So going up here in this area, right along in here, you see blues. That's easterly anomalies in the whole first part of June. Inactive phase of the MJO. But then starting about June 16th, we see westerly anomalies building in the Kelvin wave generation area. Active phase of the MJO, supposedly. And yeah, a little bit of not a westerly wind burst, just westerly winds. But now the forecast for the next week, this is the not so good part. You see easterly anomalies building, retrograding into the heart of the Kelvin wave generation area between these two tick marks again. So our active phase is all but maybe a 2-week, maybe 3 weeks, and then it's gone according to this model. So let's go look out 2 weeks. This is outgoing long wave radiation, another way of watching or monitoring what the MJO might do, forecasting. So blues are what we call negative anomalies. That means less sunlight reflecting off the ocean surface. That means more clouds. That means the active phase of the MJO. More sunlight reflecting, positive numbers here, means the high pressure, means the inactive phase of the MJO. So according to the statistic model, it looks like active phase 5 days out, fading active phase maybe 8 days out, and 2 weeks out, the active phase is gone. The inactive phase building in the Indian Ocean, trying to make its way into the West Pacific. Now, the GEFS model suggests a little bit different picture. The active phase of the MJO today kind of weakening, rebuilding a little bit, a week out, and then fading out. So basically the models are in sync, saying the active phase holding for about a week, and then it dies. All right, let's go look at another model. Here's phase diagram charts, another way of sort of monitoring position, the absolute position of the active phase of the MJO and its strength. So assume that this circle is the North Pole. You're looking down on it from above it, and the MJO moves from west to east, from the Indian Ocean over the maritime continent, into the West Pacific, across the Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Where the heavy dot is, today's the 22nd, 23rd according to this model. That's where the active phase is, so it's in the West Pacific, just barely. But the further the dot is away from this circle, if it was out here, then it would be very strong. This is a very, very weak active phase of the MJO. Here's the forecast track for the next 2 weeks. Basically staying weak, moving through the West Pacific, no real amplitude to it. According to this is the statistic model. Dynamic model, even worse. Yes, it's barely in the West Pacific, and it's supposed to just crash and basically have no strength at all 2 weeks out from now. 40-day upper level model, looking at this, it literally depicts, so the greens are areas favorable for precipitation, the yellows, oranges, unfavorable for precipitation. This looks like the inactive phase of the MJO, but it's barely there, just slowly easing its way into Central America at the end of July. No active phase to be found. Basically, there's no cohesive MJO signal at all on this chart. But then we get to the CFS model. Things are looking a little bit better according to this. This suggests, all right, again, it's the whole planet on one chart, West Pacific or Kelvin wave generation area from this tick mark to this tick mark going up. So you can see here's our inactive phase of the MJO, which is supposedly gone, though you do see a little bit of east anomalies sort of working their way into the Kelvin wave generation area. But here is supposedly an active phase, small but weak active phase, is solid contour, working its way across the West Pacific over from here to a week to, say over the next week and a half, and then out of the Kelvin wave generation area, producing pretty solid west anomalies. And this here is probably what is feeding that concept, this batch of strong west winds of that strong storm possibly building a week out south of New Zealand. But we'll see. That's actually 2 weeks out. These are 1 week intervals. But maybe, just maybe, that's what's driving it. And maybe the GEFS model is cluing in on that. Either way, this model suggests 2 weeks, 3 weeks of decent potential for storm development and westerly anomalies holding in the Kelvin wave generation area the whole way till the end of, well, at least near the end of July. All right, let's go one more. All right, here we are. This is the CFS model, but this goes out 3 months, and it switches around. Past history is in the bottom. The forecast is future. Kelvin wave generation area between these two tick marks, and you just go right up here. You see good batch of westerly winds right here. This was back in May. That was from an active phase of the MJO. Here's our next active phase of the MJO forecast. In fact, let's overlay the MJO. There you go. All right, so that was a solid contour, active phase, dotted contour, inactive phase. The inactive phase is all but gone in the Kelvin wave generation area. Again, right in this area right here. Weak active phase forecast through about mid-July with westerly anomalies in the Kelvin wave generation area. That should be feeding the jet stream. That should be supporting storm development. And then even as we get past mid-July, the MJO fades a little bit. Westerly anomalies continue. Another sort of weak active phase, but westerly anomalies continue. And the whole way to the end of the model with just no strong MJO signal indicated, though. Interesting. We overlay the low pass filter. This shows you tendency towards El Nino or low pressure bias on the date line. We were back at 3 contours, these solid contour lines here, back in February, March of this year. But notice 2 contour lines, and as of today, it's turning to 1 contour line. So this means at best a very, very weak El Nino signal, and that even retracts from the 120 west, that's California coast, retracts from there as we get into August. And then we also see the low pressure bias looking like it's trying to set up into the Indian Ocean, equally split between the Pacific and the Indian Ocean, but my bet is it's going to start building over there, and that could be the first indicators of some weak La Nina signal, but maybe not till January, February, something like that. Hard to tell, way too early. But certainly the El Nino signal appears to be dying in the Pacific, at least. I mean, it'll hold okay for the next couple of months, but after that we get into fall next year, maybe not. All right, let's take a look at water temperatures in the ocean. Enough of the MJO. Let's talk more like what's going on with El Nino. All right, so this is the East Pacific here. This is the West Pacific here. This is, on the equator, 2 degrees north and south of the equator, across the entire Pacific Ocean. We're looking for the presence of warm water moving off to the east. So we look at these, so these little X's, these are the anchors on the TAA buoys strung across the Pacific. The X's are the sensors. From that data and a little fancy modeling, you can build a composite image of what water temperatures are at depth. You see warm water in the West Pacific. This is the 30 degree isotherm, 29 degree isotherm. It's been holding right around 160. But the 28 degree isotherm, I think it was back at around 142 last week. It's retrograding a little bit to 145. And then the 24 degree isotherm, it was pushing into Equator. Now it's backtracking a little bit as well. And what that means is that easterly anomalies here in the East Pacific are probably getting the upper hand, and whatever westerly anomalies have been going on over here are kind of losing their steam. We don't have as much eastward push of warm water, maybe not so much Kelvin wave activity anymore. In fact, let's take a look. So here we are. Here is anomalies, differences from normal for this time of year. Before we were just looking at absolute temperatures. We see a broad, warm area of, 1, maybe 2 degrees above normal, but not as warm as last week. Sort of just getting washed out, not even making it into Ecuador, holding steady here, erupting at the surface mainly from, where is this? 140 west to out to the dateline or so. So mainly south of Hawaii in the dateline region. That's had been the pattern here pretty much for the past year and a half, kind of a Madoki El Nino. A strong El Nino, warm water pushes east and erupts off of Ecuador. If it's not that strong, the Kelvin waves, this ball of warm water doesn't make it as far east. It stalls somewhere south of California and erupts there. All right, let's take a look at another model. This one's suggesting the same thing. Here's our ball of warm water. This is, I guess we'll call it Kelvin wave number 4, I think it is, 4 or 5. And probably the last in the series. And the thought is after that, then you move towards La Nina. We see 1, 2, 3. 1, 2, 3. So let's say 2.5 degrees centigrade warm waters here in the central equatorial Pacific. Cool pocket off of Ecuador and the Galapagos. Could be the upwelling phase of the Kelvin wave cycle. But we also see cool water here in the far West Pacific and no signs of any new warming building in from off of the maritime continent. And we'll look at that in a minute. Sea level anomalies, this from the Jason 3 satellite, basically strip out all the swell data, the wind waves, the tides, and you see you have this yellow, that's 0 to 5 centimeters, a slight bump on the oceans, and we only care about the equator, slight bump on the ocean surface right here, and all that means is there's warm water at depth. Warm water at depth expands and then creates this bump on the ocean surface. Cool water, like over here, creates negative anomalies. This is why we're saying we don't think there's any more Kelvin wave coming, because we think temperatures are below normal at depth over here in this area, and that's where Kelvin waves originate. In fact, Kelvin wave generation area, right in here. You see, you can have all the west wind in the world you want here, but at least at depth, it doesn't look like there's any warm water there. And then upper ocean heat anomalies. All right, so you can see this is the West Pacific here. This is the East Pacific here in the west, and this is time, July 2018. So this is over a year. Look in the West Pacific how we went from having a lot of warm water here to progressively less and less and less, and if anything, building, there's the scale, building areas of cooler than normal temperatures there. All right, then we also see, we'll go back in time, July, this was Kelvin wave number 1 up here, pushing into the East Pacific, upwelling phase of the Kelvin wave cycle. Kelvin wave number 2, pretty solid. Warming water in the East Pacific, that's the hallmark of El Nino. Upwelling phase of the Kelvin wave cycle. Kelvin wave number 3, same deal, but smaller in coverage. Then here's where we are today. Kelvin wave number 4, very weak, small, cool water building here. Upwelling phase of the Kelvin wave cycle. Notice they're getting progressively stronger and lasting longer. I mean, this is probably the end. Once this guy is gone, we probably have about 3 months worth of warm water there. So what is this? June to July, August, September. Late September, you'd probably see the demise of warm water, maybe 4 months. And then 3 months after that, so September, October, November, December, late December, you'll see the jet stream starting to go, hey, there's no more warm water here. I'm going to start reconfiguring myself and responding in kind, and it would probably turn to more like a neutral to a weak La Nina kind of pattern. So let's see what's going on with temperatures at the ocean surface, because you have to have warm water at the ocean surface to support evaporation. That evaporation then supports feeding energy to the jet stream, and then that feeds, the whole cycle, the El Nino, La Nina cycle. Right now, temperatures off for Peru, a little bit cooler than normal. We saw that even at depth, there's cooler water off here. No big surprise. Here's our warm water signature, the official El Nino region from 120 west, 5 degrees north and south of the equator, out to 170 west, a box right in there. Yeah. Temperatures are warmer than normal, but not particularly warm. And the real, if you have a real El Nino, all this should be cooking hot in here. We're not seeing any of that. It's just like, it's just kind of, warm, but nothing more. Trend for the past 7 days. Now, this isn't temperatures. It's just the temperature trend for 7 days. Notice cool pockets setting up off of Ecuador on the equator, over the Galapagos, out to 130 west. Also note the same thing in the Atlantic, and a lot of times when you see this pattern developing in the Atlantic, then it manifests itself in the Pacific as well, and that appears to be what's going on. This could be more just a case of developing inactive phase of the MJO or something. Hard to know, but there is a teleconnection there, and it appears to be happening. Not any significant warming anywhere here on the equator. Absolute temperatures, the first thing you notice here is the whole of the planet is warmer than normal. No big surprise, and this is based on they take average temperatures over, I think it's a 10-year period, and then every 5 years Noaa has been having to update what is average to try to tease out where El Nino is or La Nina, and the oceans just keep getting warmer, so they got to keep revising. My sense is we're due for an update cycle sometime soon. But anyway, given that, if there was El Nino, you'd see a marked red triangle right in this area here. We're not seeing that. We're seeing weak warming on the equator. Again, the official El Nino monitoring region, they call it the Nino 3.4 region, right in this area here. Yeah, it's warmer than normal, but not a whole lot. Nino 1.2 out in here. And it's actually cold. You see cooling, just light cooling off of Peru, coming up over the Galapagos, working their way off to the east. Same deal off of Africa here. So we're in the middle of maybe some weak cooling cycle starting to develop. Actual temperatures here in the Nino 1.2 region, the area right up there alongside of Peru. Temperatures today, minus 0.422. No surprise, we saw cooling in that region. In the Nino 3.4 region, the official El Nino region, about half a degree, 0.473 above normal, and about where it's been consistently, maybe down a little for multiple months now. That's why they're declaring El Nino, because temperatures are warmer than normal, but just barely. I mean, if it was a real El Nino, we'd be up at plus 1.5 or something like that, or even above that. We're nowhere near that. The official forecast for sea surface temperatures in the Nino 3.4 region. If you believe this, temperatures were 3/4 of a degree above normal here. They are now, as we get into July, forecast to dip to 0.5, but we're down in here somewhere. We're down at 0.5 or less right now today. They're forecast to hang around 0.5 for the foreseeable future. We think that is optimistic, and if anything, these temperatures will dip down somewhere around neutral as we get into, let's say, December, January timeframe. But we'll see. I mean, just because I say it doesn't mean that it's true. The models sometimes have a sense that is not obvious, but then again, they can also be obviously wrong. So hard to say. My bet is this is biased on the high side. So to wrap things up, the good news is there has been a storm under New Zealand. Swell is in the water, pushing north. Won't arrive till a week away at minimum, if not more. And then a bunch of smaller follow-on energy for the later in the work week when that swell arrives. And then the models are saying maybe a strong system, maybe if you believe the models, a week beyond that. Certainly not aided by the active phase of the MJO, because we saw that's kind of expected to fade out. But who knows? We'll see. Beyond that, El Nino, yeah, it's in place, but it is expected to fade as well as we get later into the fall. But probably the fall will be pretty good. Then as we get deeper into winter, probably not so much surf. And rain, probably not so much for California either. So that's it for this week. Remember, you can subscribe to these forecasts. The button's down off to the right down here. Just hit the subscribe button. When we post a new forecast, you'll automatically get notified, and you'll be given the link so you can just hit it and view this forecast. We do it every week, same time, same channel. So we'll do this again next week. Looking forward to talking with you. Thanks.